Hi, my name is Alexis, and today we're going to go over local resting and action potentials in a nervous tissue. Here in this diagram, as you can see, we have our plasma membrane, and we have our sodium and potassium pumps. This is referencing the extracellular fluid toward the top, and the intercellular fluid is toward the bottom of the space. In the extracellular fluid, there's abundance of green sodium ions, and in the intercellular fluid, there's an abundance of orange potassium items, and you also see some cellular proteins that have a negative charge. In the intercellular space, it's more negatively charged due to these cellular proteins, which actually cancel out some of the positive potassium charges, making it more negative than the extracellular space. The electrical charge of the plasma membrane occurs because the difference in the extracellular space, or the negative charge, and the IFC, and this can be measured. When a neuron is at rest, the IFC, this intercellular space, is measured at negative 70 millivolts. In our system, there are sometimes disruptions of this resting polarized state, and this is when an electrical signal actually happens. When an electrical signal is present, the neurons move the sodium and potassium ions out of the IFC. So you'll see that they'll move outwards through these pumps. The stimulant membrane becomes more positive and is depolarized. The Na gates open, so these gates will open, and the sodium ions diffuse into the IFC. If the current is strong, it will progress through the plasma membrane of the soma to the axon hillock region. This is called local potential. If the current is strong and does not pass through the plasma membrane and reach the axon hillock, then the axon hillock opens the sodium and potassium gates. This is called action potential. As you can see, this movement with these arrows is showing you how through ATP converted to ADP, the potassium and sodium are fluctuating between the EFC and the IFC. The neuron will depolarize, then the sodium gates open and diffuse from the EFC to the IFC and then repolarize, and those gates will then close. After the sodium gates are closed, the potassium gates open and diffuse from the IFC into the EFC. The membrane potential changes during this shift. At the end, both of these gates will close and the sodium and potassium pumps return cations to their original position. This is the local resting and action potentials of a nervous tissue. Thank you.